Okay. Welcome everyone for our last day of the summer marathon. It's our 10th day. It's the 5th day of our week 2, where we talk about machine learning in production. We already had a lot of amazing talks. If you haven't seen some of them, go to our YouTube channel and you will be able to see all the recording. So on Monday, Jan was talking about setting up AI projects for success and how we can make sure that our projects go to production. This was a similar topic we discussed with Ben when we talked about preferring simple model to more complex model. With Lina, we talked about stakeholder management, and yesterday Duke told us how to avoid failing search projects. And today is our last day. Fabiana will talk about the importance of data quality. I would like to thank all our friends who helped us to make this event possible and help us reach out to people and promote our event. Thanks a lot. There is a link in the description, well, maybe not, but like if you go to the conference website and if you scroll all the way down, there is a section with our partners and you can check them, all this amazing communities, and they're doing cool stuff. Check them out. Finally, subscribe to our YouTube channel, not to miss our future events, and join our Slack where we talk about different data things. Last but not least, if you have any question during today, you can go to live chat and there is a pinned link. Click on this link and ask any question you want, and then we will cover these questions at the end of the presentation. That's all. Please, Fabiana, the floor is yours.
Hello, everyone. Again, it's a pleasure to be here today at the Data Talks event for this summer marathon. My name is Fabiana, and I'm Chief Data Officer at YData. And today, just like it was mentioned by Alexei, I'm going to take the next minutes to talk about something that is so dearly to me, and also for most of us in the data science community, the data quality and its importance. So as data scientists, data science continues to gain importance for businesses. Organizations will keep seeking to understand how they can develop, integrate, and leverage machine learning-based solutions. And to rush in the development and to leverage machine learning to build its differentiation in the organizations, it's a reality. As we can see here, nowadays, 76% of organizations are prioritizing AI and machine learning over other IT initiatives. At the same time, 64% of organizations have increased AI and machine learning priority only in the past year. This is all according to Algorithmia's latest report, for example. So knowing this, we understand that data scientists are poised to take a unique leadership role in organizations. After all, data is the way to drive innovation and define a new strategy for the businesses. But with all this potential that we already acknowledged for quite some time, why are we still not there? The truth is, there are too many projects, AI projects still failing. It is said that is around 85% of them. I'm sure that many of you have already heard about this metric, and you might be tempted to think that this is no longer so true. But unfortunately, this number is still pretty real. And some major causes are usually related with data, specifically either to the limited access to data related to privacy and security constraints, or simply because the data doesn't have the expected or the needed quality. Very recently, Google have released a paper about the importance and impact of data quality. I particularly like the way they have put the importance of data for the AI development. Data quality carries an elevated significance and high stakes in the AI development process due to the the way it impacts and weights on the downstream applications. For some reason that we do not know, or maybe we don't understand yet, data nowadays is probably one of the most undervalued and de-glamorized aspects of AI. As we can see here, they have created this concept of data cascades. So in each step of the AI process, they have defined how much it will weight the impact in the downstream applications and the downstream path steps that involve all the process of AI development. And to be truth, and based what I've seen in terms of development of machine learning in organizations, on a day-to-day basis, we keep very focused on getting models to perform extremely well and fully optimized. But what if the biggest gains were on the data side? And what is in the end the downstream impact of not solving those data quality issues right at the beginning? As I mentioned, this is what are the so-called cascades and are so important to understanding the data quality as a whole. And they can be described as compounding events. They are preservative, invisible, and delayed, but often could be avoided. And in order to avoid these issues, it means that we have to be capable to detect them. But nevertheless, the data quality issues in AI are more often than not addressed with the wrong tools that we were created for and fitted for other technology problems. And why? You might be asking. Well, to answer the question, might be useful to first tackle what is the definition really of data quality, and to understand that data quality still has different phases and different aspects to consider depending on the stage of AI where you are. So, in a nutshell, we can describe that our data has enough quality. It translates and stores the multiple dimensions of the use cases that we are targeting. Also, whether it's accessible in a timely manner and it's timely relevant. Also, whether this data that you are using for your use case, it's accurate and complete, consistent and with the integrity ensured. And finally, this data must be unique and valid for the problem that we are solving. Data quality, as I mentioned, can be seen and measured in different ways at different stages of the machine learning flow. It can start with the definition of what data will be required to solve a certain use case and how it will be collected, to all the way down to the end of the flow, where you have to measure the data drifts, for example, and keep the data observability in check when your models are in production. For the purpose of today's talk, I will be focusing specifically at the step where the data stakes of AI, the stakes of data in AI are bigger or considered to be bigger: data collection and preparation. So, on that regard, I brought you some horror stories, or some stories that we all have seen around the newspapers in the latest times. You might be thinking, okay, AI is so well developed right now. So what might be the data quality issues that we face on the stage of data collection and data preparation, really? So there are plenty, and even the most experienced companies in the AI space are sometimes strict by the complexity of the data behavior. For example, Google once developed a model to diagnose retinal disease that was super accurate in a lab, but whenever this model was put into production to be used in real humans, it failed completely. In reality here, what happened was as simple as the data that they were using to develop the model was not acquired and did not have the same issues that the real data had, of course. And as they were so different, and in this case, the model was developed in a control environment, of course, when it arrives production and it arrives to solve real human problems, it didn't work out. Also, another one, and this one create a lot of controversy. So this was during COVID time, so schools could not be open, and the British government decided to try to automate the school grading systems. So in that sense, they developed this model that in a nutshell would be estimating how the students would have performed in the exams if they had done the exams. What they did not expect was that there was a lot of bias present in the data that was not addressed at all for the development of the model, which not only affected the end results of the model, of course, but also the trust in AI and automated systems by the population. Because in the end, there was students being penalized because of who they were, where they lived, and that was not taken in consideration. And this is all about data quality, and this is all about capturing behaviors that are not expected or not so obvious, but they are hidden within your data. Taking back here, and this takes us to the needs of a new approach and the adoption of a new approach. So far, we followed what it is called to be a model-centric approach. And now we need to maybe try and adopt a more data-centric. To be more specific here, and I will oversimplify a bit and describe that an AI system is basically a combination of code and data. And for an AI system to be successful, we can think about it as the right balance between the code, or meaning the algorithm or the model, and the data. Besides Google and about data quality in this data-centric approach, another individual also shared their understanding of the high stakes of data quality in AI very recently. It was Andrew Ng that shared with us a perspective, this perspective that I'm sharing with you today, the need to become data-centric. If we go and see, when dealing with Kaggle data sets, it is expected that we follow a 100% model-centric approach. This because the data in its essence is very well behaved, which means that to improve the solutions, the focus has to be taken only in one element, the code. So you have to do hyperparameter tuning, you have to optimize as much as possible your architecture or the choice of your model. So that's your focus. The data is great, or at least the problems are not massive. So you don't need to take too much time in this element. But in reality, and with the data from industry, this is completely different. And one of the major facts that leads to the why data quality is not only hard to measure, but also the tooling available is more limited, is related to the fact that until now, the model-centric approach was the choice or the way to go. Everyone assumed that although data preparation, you had to do some processing, and of course it takes time, but was not where the major gains were. The major gains were always put it on the side of the model. To give you a concrete example and for a better understanding of this concept, I brought here the steel sheets, the use case detection. So here our objective was to detect defects on the steel sheets. And assuming the series of image of steel sheets, we wanted to develop the best model possible, and also to understand what would be a defect when detected in an automated manner. In reality, there were around 39 different defects to detect. By developing a computer vision model with very well tuned hyperparameters, we were able to achieve the 76.2% accuracy baseline. But the goal was to achieve the 90%. And you might be asking, like, how is it that even possible? So you trained the data, you also already did the hyperparameter tuning, that's fine now. Well, although the 76.2% is a very, very good baseline, it's possible to get it better. So what do you think if I told you that this is possible just by detecting very well the inconsistencies on the labeling, cleaning those labels, and only this step would guarantee me and ensuring me the 93.2% accuracy? Yes, this is what happens when you deal with the data quality issue in the right stage of your data. So this was a result that was possible with the combination, of course, of the model-centric approach when you do the right hyperparameter tuning or the right amount, plus taking care and cleaning and going deeper into solving the problems that your original data has. The potential of gearing our attention towards data quality and the approach of adopting this data-centric approach is huge. And definitely, I've shown here as an example of us applying this concept to computer vision and to cases where we are working with images. But this is also true for areas such as NLP, time series, or even tabular data. And from my perspective, following a bit the data-centric approach, the go big or go home view about data collection it might come to an end in a way. So sometimes we heard that the more data, the better. If you have more data, you can do more things. Well, it's not like, of course, it's not saying this is completely wrong. It is not, but it's, of course, we know it is very hard to be fully sure whether we have an amount of data that is enough. It is usually a matter of understanding, based on the amount of data that you have, whether you are able or not to generalize models into production. This is how you define whether you have enough data or not. And the more data that we have available, another problem also arises, which is the noise available on that data, which means that we can, of course, with the right choice of parameters and model, achieve more generalizable results. But in my opinion, I think it would be far more performant to work with smaller data sets that are representative, valid, complete, and with unique values to train the models. Because in the end, to have a lot of data available also brings different challenges in what concerns data system architectures, the scalability of those architectures, and in the end, the effort that you have to invest in order to develop a model that is able to denoise the data through hyperparameter tuning. Self-awareness of data, which is what I think is the most important part to understand the quality of your data at the step of the data preparation, not only makes the process of training models more efficient and performance, but also reduces the costs required in terms of infrastructure. Of course, if you have more data, you have to deal with the challenges and of having the right infrastructure to train models on that huge amount of data. Another plus from the self-awareness and be concerned really with the data quality to be achieved comes with what I call the data explainability and causality. So this allows you, because explainability is not only at the level of the models, right? You can also understand what the data is trying to tell you. And this is where the self-awareness of your data quality can help you avoiding issues related with black box models that are hard to understand, fairness, or even biases. And the benefits are, of course, are huge if you are going to measure them. The path of investing in clean and noise data sets for me will become the differentiator and the edge for many organizations that decide or are looking into investing in AI for their businesses. And to help companies and organizations to improve and automate the quality of the data, happily, we also see new tooling emerging. So, of course, we already had data wrangling in the past. We already did exploratory data analysis, but now we can go deeper and increase the self-awareness and understanding on the data that we have, plus combining with new tooling that help us out to solve some issues that are more complex or different in terms of the data. These solutions are, for example, synthetic data generation with deep generative models, data labeling or data selection based in active learning, so you can filter and understand what data gives you more information for the model that you are developing, and also new profiling solutions or solutions that allow you to do some self-awareness on the data that do leverage Bayesian networks are currently being developed. And this is something that we are seeing as a trend also in the open source. So a lot of the open source is now releasing such solutions that will help us with the problems and dealing with the problems that arise in terms of data quality for data collection and at the stage of the processing itself. And more recently, I don't know if you can see, let me click on this, to emphasize a bit the need for research in the area of data quality, Google is going to release a new feature in its platform, which is called Know Your Data. They have developed this for images, and essentially they help you understand how your data looks like, what your images are depicting, so you can really develop your models knowing much more about your data than you knew before. And this feature is being made available to the users so they can improve the quality of their data, in this case of their image sets, but also to fight problems such as fairness and biases that a lot of the times are hidden within the data itself. And of course, to wrap up here, let's not forget that in the space of data preparation and data quality, we cannot see data quality alone only during the process of developing the model. So data quality, or the insurance of data quality, exists in different steps of the ML flow, and specifically the step of data preparation is just one piece of the complex workflow for machine learning development. So in fact, to ensure that we achieve good data quality, MLOps, it's essential. It's where all the dots are connected, and the tooling that the MLOps space offers, it's what allows us to take the data quality to the next step and really ensure consistency, reproducibility, and lineage. And maybe just to give you some quick examples of this importance, and some of the problems really in the industry that I've seen, they have came exactly because of the lack of tools, such as, for example, feature stores. they can be very handy, for example, to keep the reproducibility of the data preparation steps that you are taking. Maybe another very useful example is also how data lineage and tooling for data lineage can ensure us that we keep track of the improvements that we are achieving with the data preparation and even the data collection. So each and every step has to be really well interconnected, and for that reason, that's why I'm presenting you here the AI canonical step concept, which is an initiative that brings together what is considered to be the essential building blocks for the artificial intelligence applications. And really, I could not stress enough how important it is really for you to have a proper architecture, data architecture from an end-to-end perspective in the ML flow to ensure that your data quality is on point. Many of the problems come from not having the right tooling available. That's why I'm also keeping this topic under the importance of data quality. Well, that's all from my side. I just want you to leave you with a quote that I really enjoyed, and I think it makes so much sense for this presentation. The truth is that the problems usually are not the algorithms, but the dirty data fed into it. This was said by Anna Beck, the head of AI for social good at Intel.
Yeah, thank you. Yeah, I do have a couple of questions. Is it okay if I ask?
Yes, sure.
So like I liked your example of with steel, that where you did some parameter tuning and it didn't bring any visible effect, while when you played with the data and you cleaned the data, it brought a significant improvement. So I'm curious to know what kind of improvements did you do? What kind of cleaning did you perform to, if it was your project, or what did you do there to actually to have this improvement?
This was the project presented by Andrew and G.
Oh, okay.
But essentially, what was done was the work at the labels stage. So as this was a classification problem, and they were looking into an already labeled data set, what happened is that this data set had some inconsistencies or some labels that were not clear. And there was some boundaries or noise, meaning some labels were a bit fuzzy or not very well defined, which is what usually might bring information to your model that might, let's say, confuse the model. So what was done was exactly this filtering and this process on the side of the data to correct labels that were wrong, or to clean more noisy labels. This is what achieved here the better performance.
Let's wait till Fabiana is back. So maybe while we're waiting for her, I wanted to say that there is a nice trick I learned on Kaggle, that let's say you have a data set and you want to train a model on that. In this data set has some wrong labels there. What you can do is you can train a model on your training data set. You can overfeed it a bit and then apply this model to the same. I was just telling about the trick that I learned on Kaggle. So on Kaggle, let's say you have a data set and you train a model on this data set, and then you take this model and you apply it to the same data set. And then you see where you have the disagreement between the model prediction and the actual label. And these examples are often incorrectly classified examples. And then depending on how large your data set is, what you can do is just, first of all, you can just manually look at this and analyze and see, okay, this label is not correct. Or if this data set is big, what you can do is you can simply throw away all this data And sometimes on Kaggle, this results into a better model. Like when you train another model on top of the data that is not removed, that stays, then sometimes it results in a better model. Yeah. So how's your internet? Is it better? I think you're muted.
Yes, I was muted. Yes, it's what you were saying. It resonates a bit with this simpler tactic that Andrew and G shown. But sometimes what for us might be obvious, or for in some cases for Kaggle, many people do not know that these simple tricks or this simple stuff that can be done with data can indeed achieve a better results, or models that are generalizable enough.
Mm-hmm. Yeah. You probably wanted to, like, because the connection broke when you were saying something. Do you remember what you wanted to say?
No,
No.
not at the moment. So if I recall, I mentioned you had a few questions. If you wanted.
Yes, and I also want to remind, if for those who are watching, if you want to ask a question, there is a link in the live chat that is pinned. You can just go there and ask a question. Yeah, so I also wanted to ask about this concept of data explainability. So I know what model explainability is. So for a model explainability, so you have a model that could be a black box model, and then you had some instance, some observation, then you apply the model to this observation, and you can use different explainability tools to understand why did the model make this decision. So what led to this decision? And I'm wondering, what is data explainability? Is it similar?
On the data, yeah, it is, and I would put it on the side of data causality, really. So how the data in the end, in how the records in each different record, in each different behavior that you see in the data, how they are impacting in the end the predictions and the results that we are getting when building a model. So this kind of self-awareness, or this understanding, or as I like it to say, the explainability that you can get from this gives you the understanding of some problems that your data might have, how, and explain better why sometimes your models are achieving certain results. Those results might be influenced not by your hyperparameter choice, or by the choice of your networks, or the model that you chose to use for a certain use case, but rather what you have within the data and how the data was really collected. In that sense, this is where I would put what is data explainability.
I'm just trying to understand how it might look like. To me, what you describe sounds very similar to model explainability, right? So you have this bunch of data points, and then for all of these data points, you can understand why the model made this decision, right? You just link this model explainability back to data, right? And you can see maybe what kind of data points influence this decision, or it's different. Hey, are you back? Can you hear me?
Now, yes, I didn't hear the question. It seems like they are with problems not only in the network but also in the lights. The energy here. Sorry for this.
Yeah, no worries. So my question is I'm trying to understand what is the connection between the two, the model explainability and data explainability. Like, are they, can one exist without the other? Like, can we have data explainability without model explainability? Because I think the goal here is to link the decision back to, like, we explain for all separates the instances, and then we link it back to the data points, right?
I agree. I do think there is a dependent relation there. So to have data explainability without the model itself of course, you can understand how the data is, but essentially model explainability is also very important for you to ensure that you understand how it is your data. It's the same as also data quality and how to measure data quality. Although it is a space that you go and see in the literature, it doesn't exist that much, especially for the process step of data preparation. And how do you measure data quality and how you achieve the improvements in the data? There are not many research about it, but usually the way you can measure how data is, and well, if it's good enough, is through models. So I like to do this parallel because for me it's exactly the same dependence relationship that we have here.
And what are the tools that you can use for that? Do you go with the usual like lime and this sharp values, or it's different?
Yeah, you can use those, but you can also leverage a lot, for example, Bayesian networks for this process. Bayesian networks, in some cases, active learning can also help a lot, which is what we were talking a bit about on the label side. All of this is what is used not only to measure the quality, but also to measure a bit to understand better the data. Okay. I would put these three as the main tools that you can leverage for that.
Mm-hmm. Yeah, thank you. So we have a couple of questions. So the first question is from Akshat, is how do I assess the quality of data in numeric terms for unstructured data?
When you say unstructured data, you say what kind of unstructured?
Well,
NLP, images?
For me, maybe Akshat, you can mention that. To me, usually it's text and images.
Yeah, exactly. So it will depend. Also, the nature of the data does impact a lot on how you are going and what you are using to measure the quality. To be fair, my specialty is on structured data in time series. And they are, in terms of nature, very different from what you do on images. But for example, if you go and see here the project that Google is about to release, part of the measurement of the data quality and also understanding how the data is done by exploring the image itself. So what content does the image has? It's not so much measuring pixel, or because there's also all that question around how do you say that an image has a nice quality in terms of pixel wise, and also if it's interpretable, let's say. But in this case, what they did was really to extract some statistics on the for example, on the labels, understanding in terms of content what the image had, what the image didn't, in terms of color wise, and so on. So this was the metrics they extracted, and I'm guessing this is the research that is being done at the level of the image space. About that specifically, I would prefer to not talk about that because I really do not have the expertise needed.
So I guess the idea here is you turn somehow your unstructured data into structured data using a neural network or something else, and then you use the tools from the structured data space. And you said your specialty is more time series. Sorry, I think I interrupted.
Exactly.
Yeah. So I wanted to ask you, how do you do this there in when you have your structured time series or tabular data?
Yeah. So on those cases, and also the challenge there is that, well, different from images, the data can vary a bit more in a sense of the distributions itself. Not so you have to take that in consideration. Of course, you can start for the most basic stuff where you are just checking skewness, missingness. Of course, all of those have impact on the quality. but then you want to understand, for example, in terms of missingness, how is the missingness being done? Because missingness shouldn't be only measured in a univariate manner. So you have always to check in a multivariate manner what is impacting, what is, for example, is there any other correlation that is taking for you to have in your data missing values? The same happens for the time series purpose. Then you have to check the variability that your data set is guaranteeing in terms of different behaviors. You identify different behaviors within your data. And I'm not talking about just following the labels. So you have imbalanced data set because one label was not, is less represented than the others. I'm really talking about leveraging a lot of unsupervised learning to understand how your data set is behaving in terms of patterns that are found, group those patterns, understand whether those patterns are well represented, for example. You also have I guess for the time series, you also have to then identify whether in terms of you have a stationary or not time series, whether the combination with the other series that you have, if you have enough to predict. So all of this is using machine learning to help us out and really understanding the data. A lot of unsupervised learning is what we use to measure the quality of the data, for example.
Thank you. And yeah, actually, Akshat said that he meant NLP and text by unstructured data. And then the also question from Akshat is another one is many data scientists work for clients and the clients expect quick results. So how do you explain the importance of data quality to clients? How do you convince them that this is an important thing and you need to invest time on this?
That's a very good question, because that happens a lot, right? So in terms of and we are talking here about machine learning in production. One of the things that is most common is that you arrive to a project, you are told that the client has enough data for you to deliver the use case, and when you arrive, either the labels doesn't exist or the data, for example, doesn't even answer the question that you want to see answered. A lot of the time, you cannot just go ahead and say, "Listen, data quality is important." It's hard for them to not understand that such a clean data set, because sometimes they are clean. The only problem is that they are missing information. You have to sometimes you have to really do the hard way. So you have to fail. You have to show how it is failing. You have to show our model, when it arrives to production, doesn't answer the question. To only afterwards you can show the value of going for a harder path. Maybe sometimes, and this happens, I've seen it happen. Maybe sometimes you cannot right away invest in a machine learning solution. Maybe you have to redo the data collection, and those are the worst case scenarios. And when you need to redo the data collection, you have to wait maybe a full year to start again building models. But usually, I haven't seen yet a better way to show people the importance of data quality other than failing.
Yeah, but it's also, I guess, a bit dangerous, especially if you work with clients, and then clients might think, okay, this failed, let's try somebody else.
Exactly. So you have to be really careful when doing that. Exactly. In a very controlled environment as well.
Yeah,
don't just release the model that you know you will fail into, like, I don't know, a real production system.
But also your example about this steel problem, that when you improve the quality of data and then you can show that this is how the quality improves, maybe it could be also a good argument, right? You can show examples from the industry maybe not necessarily steel, because it's not always relatable to everyone. I have no knowledge of steel, but example is good. And I think you can find other examples. And actually, there is a comment from David that last week Andrew Ng launched a data-centric competition, which the algorithm is fixed, but the participants have to work on data in order to improve the results.
Exactly.
So this is cool, and you probably can show this. Hey, look, there is this competition. You see how much it's possible to improve the performance just by tweaking data. Maybe it's a good
I think
idea.
so. I think so. And especially if you are able to do that parallel within the same industry that your customer is working. Because one of the things that we also commonly find is that although we know that sometimes the importance of data quality is transversal, it's universal, right? It goes to all the data sets. It's important. Sometimes it's harder for someone, I don't know, from the energy industry, understand that the same improvement that was achieved through data quality in a totally different industry, I don't know, such as financial services, also applies to their data. Okay, so definitely, if you are able to show through a use case, a real use case in the same industry, I think that that's a very good selling point.
Yeah, I guess if you work in advertisement or marketing and you bring up this steel example, maybe it's not always
Exactly.
super relatable.
Exactly.
Um, what is your opinion on synthetic data generation? Does it affect data quality?
I'm a strong advocate of synthetic data for sure. And I think synthetic data can be the path, part of the path to achieve better data quality. Not saying it's the unique solution or the best option for data quality, but in some cases, I think it's for sure core for the to getting there. We have seen that already especially in the image space, where we go for example, self-driving cars, and you want to simulate, get images or get new scenarios like in the snow, in the wind, get more diversity in terms of what information and data that you have available. That is a way to ensure better data quality for better generalization of the model. And I'm pretty sure that this will we will see in the next few years this happening also for other areas where synthetic data will not only play a role in this generalization of models, but also to solve problems such as bias, fairness, and privacy as well, the access to data.
I can imagine how these tools, synthetic data generation tools, work for computer vision cases, because there are games, right? So, and these games are pretty realistic, very realistic. You can generate a lot of things for computer vision cases. Like you can generate all the
Yeah.
kind of objects, you can generate cars, you can generate all this, I don't know, for self-driving cars, you can generate all possible scenarios on the road. Maybe not all
Yes.
possible, but quite a lot. But I'm
Yeah.
wondering if what is going on in other areas, like let's say in text or time series or tabular
Yeah.
data. Do we have something similar?
Yes. Even simulation as well. So just like with images, you see, I don't know, the necessity of simulating the same car in a different kind of scenario. The same happens, for example, in financial services, where you do use simulation, for example, to calculate risk. And you can do that exactly through synthetic data. So you can simulate new scenarios for a certain profile and try to understand how it would behave. This is a use case, and this is one of the applications. But you can also see, for example, for fraud detection, even for failure detection, how synthetic data can help to balance the data set, or to get the data set more balanced, but with more variability.
Mhm.
Because different from just copying the behaviors that already exist. A lot of the techniques that we see nowadays brings variability and flexibility on the generation of synthetic data. Of course, it will depend on the use case, but we see the exact same application of augmentation, balancing, simulation that we see in images, very easily translated for other types of data.
Thank you. Then the next question we have is about data quality frameworks. Do you have any recommendations? Which one to use?
We develop our own. So to be completely honest, in the space where we work, which is the structured data, there are not many tools available. The majority that you see around what could be called data quality is exploratory data analysis. And you have some open projects about that, for example, data prep. But it's all around that. You can also see some literature around Bayesian networks that is very interesting, and you can see some research work open about it that I do highly recommend. I cannot recall now one specifically, but if you search for Bayesian networks and data interpretability, you can find that. But on the space of data images, well, I guess I can recommend this one that is called Know Your Data, that is about to be released.
And the question that we have next is about any research paper on data quality. I think you partly answered that. So your answer was to look up Bayesian networks data interpretability, right? And there are some.
And there is this one that I shown in the beginning of the presentation that is from Google, which is about the high stakes of data quality in machine learning, which I do highly recommend reading. It's very interesting, and they do explore a bit in more depth the impacts of the fixing data quality at different stages. So it's very interesting more for acknowledge rather to have a solution on how to measure and so on. But it's still, I would still recommend it a lot.
And the follow-up, so you mentioned you developed your own tool for assessing data quality. So how can people find it?
Nowadays it's not yet open, but we plan to open it until the end of the year. So we do have, we are very connected to the MLOps community. So as soon as we release, we will make it publicly through the community.
Okay, cool. Is there anyone on social media you follow regarding data quality?
Let me think. I think for now, the biggest advocates for data quality is really Anna Beckett from Intel, and also Andrew Ng, that is clearly doing a very good job in having the people understanding the impact of data quality and the need to go for a more data-centric approach.
And yeah, I think people should also follow you. And when you make this announcement, when you make this tool,
Exactly.
You'll probably announce it on Twitter and LinkedIn as well. So people should go and follow you on these social networks, and yeah, that's
exactly.
To know
and we are always open also to listen. So if you want to share, people wants to share their needs in terms of measuring data quality, their needs in terms of or hard times they have in terms of understanding their data. If you want, well, I'm always happy to have a quick chat and know a bit more.
I'll put your contact details in the description. So I have your Twitter and I have your LinkedIn. So there is one last question we have from David, is what do you think are the main challenges of this data-centric approach? Is it scalability or something else?
I think a bit of both. Even scalability can become part of challenging because also, but I would say the main one is the lack of research on the area. So for now, your ability to measure data quality is highly linked with models or model performance, which means that for you to know and understand the data quality, you need to know the question that you want to answer. And sometimes for you to know what question you want to answer, that means that even during the process of data collection, you need to have thought about that question. And I think that's the biggest problem, because sometimes you do collect the data, you do have the data, but it's not answering the question. So it doesn't matter if you are using the best techniques to measure data quality, if in the end the problem was really you do not have useful data. So I think that's one of the biggest challenge. So how can you ensure that the path of data quality is well interconnected since the beginning until the end? And I think that's where things can get trickier.
And you mentioned that to convince that data quality is important, sometimes it takes sometimes you need to fail, right? And to convince that, okay, then it's probably a good argument to invest into data quality, and then you have this end-to-end thing.
Exactly.
Okay. Anything else you want to say before we wrap up?
Well, I hope people have enjoyed and have enjoyed the raise of awareness around this subject. I know that we all heard the garbage in, garbage out, but sometimes it's very easy to forget or to miss some things around the hidden patterns that we see within the data. And well, if there are any questions, anything, Alexei will leave my contacts. Feel free to reach out. Happy to connect.
Mm-hmm. Yes.
And also, I want to thank you for the initiative. It was very interesting.
Yeah, thanks a lot for joining us, and thanks a lot everyone for joining us today and for asking questions. And this is actually the last day of our conference. I must admit I'm a bit tired after 10 days. So thanks a lot to everyone who joined and listened in, watched and asked questions. And yeah, so maybe in half a year I'll organize something else. So thanks a lot.
Thank you so much.
Yeah, and have a great day.
You too. Take care.
Goodbye.